Welcome friends. We are discussing module 6 of network theory. This module is mainly two-port network. Previously we have discussed different types of two-port networks and their interrelationship. To continue our discussion on two-port network, let us move forward. We have next topic with us, and that is the concept of reciprocal network, and following to that we have concept of symmetrical network. Now let us try to understand what is a reciprocal network and what is a symmetrical network. Let us say we have a network with a input port V1 I1 and also has a output port V2 I2. Input port has the voltage and current V1 I1 respectively, and output port has the voltage current V2 I2 respectively. Now this V1 and V2 are called excitation variable. Excitation variable. On the other hand, I1 and I2 are called response variable. Now let us consider we have that network. Excite this network from the input side. Let us say we have given the voltage V1 and we are having a current I1 at the input port. However, at the output side we are making it short circuited. So as a result we will get a current of minus I2. So why I am taking this one as a minus? Because as far as the two-port network topology, the conventional current direction I1 and I2 is flowing into the network, right? It is not away from the network. So since at the output side or the secondary side, since the current flowing is away from the network, so we are considering this to be a minus I2. So in this case we consider V1 as our excitation variable and I2, or rather minus I2, whatever, it is our response variable. Okay, so we take the ratio, that is the response variable towards the excitation variable. And if we do the same thing reversely, that means if we have the network, same network, now if we excite that network from the output side, that means we are giving a voltage of V2 that injects a current I2. Now if we make input side short circuited, should get a current of minus I1 at the input side. So let us take the ratio of excitation variable, let us take the ratio of response variable, which is I1, to the excitation variable, which is V2. So in both the cases, if these two ratios are same, then that network is called reciprocal network. So a reciprocal network is basically that network where the ratio of response variable to the excitation variable remains same even if position of the individual variables are interchanged. Position of the individual variables are interchanged. So what is the condition? I2 by V1 is equal to I1 by V2. This should be the condition. Now, one of the primary component, or rather you can say standard procedure to calculate the different condition of reciprocal network, that you must short circuit the other side. Okay, that means if you are exciting the network from input side, you must short circuit it from output side. That means you must make V2 is equal to 0 in order to short circuiting it. Okay, so that is the normal procedure. So now let us quickly going through the different parameters. If we want to represent the condition of reciprocity in terms of them, or in terms of Z parameter, Y parameter and so on, then what are the different conditions? So let us have a quick derivation. So let us start with first Z parameter. So these are the fundamental equations of Z parameter. V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2 as per equation 1a and 1b. Now as per the standard process, we make V2 is equal to 0. V2 is equal to 0 means if this is the network, then we must make output port short circuited. So we are getting V2 is equal to 0. So this current becomes minus I2. So this current becomes minus I2, and from the input side, we as usual we are giving some voltage that injects some current I1. So if V2 is equal to 0, so from equation 1b we can write I1 is equal to Z22 by Z21 into minus I2. So that is what we are getting from equation 1b. It is from equation 1b. So using the first equation, that means equation 1a, if you substitute I1 is equal to this, so let us substitute V1 is equal to Z1 into Z22 by Z1 into I2 plus Z12 into minus I2. So if you substitute or if you solve, you will get this result. Z11 Z22 minus Z12 Z21 divided by Z21. So if you take the ratio I2 by V1, so it will be coming out as Z21 divided by delta Z. Z21 divided by delta Z, where delta Z is equal to Z11 Z22 minus Z12 Z21. Now if you conduct the similar approach from the other side, that means if we have the same network, now you are exciting it from the output side, that means V2, it is injecting some current I2, and we are making input side shorted, so V1 becomes 0. So we will get a similar relation, I1 by V2 is equal to Z12 divided by delta Z. So if you, as per the reciprocal condition, as per the reciprocal network, you should have I2 by V1 is equal to I1 by V2. So with this, from equation 1d and 1e, this is the condition. It should be Z12 is equal to Z21. Z12 is equal to Z21. So what does it mean? For if any network for any network, if you solve it for Z parameters, if you have any encounter with any network and if you solve Z parameter and if you find this relation Z12 is equal to Z21, then you must say this network must be a reciprocal network. This network must be a reciprocal network. That is the meaning. So if you find this result by solving any network, that type of network is called reciprocal network. So the moving on to the next parameter, it is Y parameter. So I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. Okay. So the same network, we will follow the same process. We have the network. First, we are injecting or we are exciting it from the input side. Current flowing to the input side is I1 and we are making short circuit at the output side. So V2 becomes 0 and current becomes minus I2. So let us make V2 is equal to 0. Let us make V2 is equal to 0. So from equation 2b, we can straight away write. So if when V2 is equal to 0, this term vanishes. So I2 becomes Y21 V1. I2 becomes Y21 V1, and since the direction of the current changes, so I2 must be replaced by minus I2. I2 should be replaced by minus I2. So from this equation, you can straight away write I2 by V1 is equal to minus Y21. I2 by V1 is equal to minus Y21. And if we conduct similar approach, so same network, now if we give supply or energy from the output side V2, which is giving some current I2, and if we making short circuiting it from the input side, so current becomes minus I1. So we will get the similar relation I1 by V2 is equal to minus Y12. So from the definition, you know I2 by V1 is equal to I1 by V2. So from there you can understand Y12 is equal to Y21 becomes the reciprocal network, becomes the condition for Y parameters. Determine a network whether it is a reciprocal or not. So if any network, if you come across and if you solve it for Y parameters and if you find this result Y12 is equal to Y21, then it immediately follows that that network should be a reciprocal network. So the moving on. Now let us solve it for ABCD parameter, under which condition you can say that ABCD parameters, it is the network is reciprocal. So we have the fundamental equation for ABCD parameters are V1 is equal to AV2 plus BI2 and I1 is equal to CV2 plus DI2. So we have that network. So let us say we have excited it from the primary side and current is I1 and we are making it the short circuit from the secondary side. So V2 becomes 0 and current becomes minus I2 as it reverses its direction. So when you make V2 is equal to 0, then it becomes from the equation 3a, from equation 3a, it becomes V1 is equal to B into minus I2. Now I2 is replaced with minus I2 because of this fact, current is reverses its direction. So from this equation you can directly write the ratio I2 by V1 is equal to I2 by V1, that is equal to minus 1 by B. That is the first condition. And secondly, if you conduct the similar relation by making V1 is equal to 0, so from the equation 3a, you will get a relation I2 is equal to minus A by B V2. So it is from equation 3a. And if you substitute this value I2 in equation 3b, then I1 becomes minus I1 because you are doing it from the secondary side. V2, which is injecting a current I2, you are making sorting primary side, so V1 equal to 0, so current becomes minus I1. So here current is minus I1, so C V2 as it is plus D into I2. Now you should substitute D is equal to this. So if you solve, I1 by V2 will become AD minus BC by B. So from the definition, if you consider I1 by V2 is equal to I2 by V1, so that which immediately follows the magnitude of AD minus BC, the magnitude of AD minus BC should be equal to 1. So if you solve any ABCD parameter problem and if you find this condition, then you can directly say that that network should be a reciprocal network. Finally, in terms of H parameters, we have these fundamental equations. V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. We have that network. We are exciting it from the primary side, V1. We are having current I1 at the primary side. Now let us make short circuit at the secondary to make V2 is equal to 0. Current will become minus I2. So when you make V2 is equal to 0, it immediately follows. So these two terms will be gone. So it can follow immediately I2 by V1. I2 by V1. If you divide these two equations, I2 by V1 is equal to H21 by H11. This is immediately follows. And by applying the similar approach, the same network, if you now excite it from the secondary side by a voltage V2, and if you are making short circuit at the primary side to make it 0, current becomes reverse minus I1. So V1 is equal to 0. So from the equation 4a, if V1 is equal to 0, so you can directly get the relationship between I1 and V2 by this. So when you compare these two, it follows H12 is equal to H21. So when in terms of Z parameters we have derived, it is Z12 is equal to Z21. Z12 is equal to Z21. In terms of Y parameter, we have derived Y12 is equal to Y21. In terms of ABCD parameter, we derived the magnitude of AD minus BC must be equal to 1. And in terms of H parameters, we have derived H12 is equal to H21. So these are the conditions for a network to be a reciprocal one. That means if you are given a network and if you solve any one of these four parameters and if you find the respective result, that means if you find H12 is equal to H21, then you can immediately say that that network is a reciprocal one. Okay. So a network can be reciprocal or not can be proved for differently. Whether it can be proved by impedance parameter or admittance parameter or transmission parameters or H parameters depending on your wish. So with this, I am ending here. So in the next session, we shall discuss the symmetrical network. Thank you.